differential calculus. As you know that there are two parts of calculus, integral and differential. So here we are today starting with differential calculus. So as you know that in calculus we study the functions, the rate of variation of functions in differential calculus. There are various types of functions which we will also be discussing. So in calculus, differential calculus, we have to find the derivatives mainly. Derivative of a function, derivative of a product of functions, which is also a composite function, or the different types of functions, different types of compositions of the functions, like ratio of a function, that is another function, addition of or different subtraction of two different types of functions. So these all create new functions. So we have to find the derivative. So first of all, we will discuss what is a derivative. You know commonly that y is equal to fx is a function. So what we do is to find the derivative, find dy by dx. To find the derivative again, that is called the second derivative, we again differentiate this with respect to x, d2y by dx square, and so on. But first of all, you should know what is a derivative. So let me explain this. What is a derivative? Suppose we have a function given by y is equal to fx. Here x is the variable, the value of which is to be inserted. So it is independent variable and y is the dependent variable because the value of y depends upon x. So you can write several types of functions like y equal to x square, y is equal to x cube, y equal to sine x, and so on. These are different types of functions. So if I plot the graph of this function, this is the y-axis and x-axis. Suppose the function looks like this. It is not necessary that every function looks like this. This is just a graph which I have plotted. So I take any value of, say, here x is equal to, suppose, a. So corresponding to this, the value of y will be fa. When I put x equal to a in this, the value of y will be fa. Suppose this point is a. And if we move along the graph in both directions, x-axis and y-axis, say along x-axis I move by a certain distance and reach this point. So this distance is h. This distance is h. So we can write some value of x and y here. So at x is equal to this is a from the origin, this is x equal to a, and this is h. So here the value of x is a plus h. So x is a plus h, so y naturally will be equal to f of a plus h. So these are the values of y. So you can write down the coordinates of 2 points. The x coordinate here, suppose this point is b. X coordinate is a plus h and y coordinate is f of a plus h. At a, the x coordinate is a and y coordinate is fa. So as we move from a to b, so I will draw a straight line joining a and b. This is the line joining a and b. As we move from a to b, actually we have to move along the curve, but the interval we have taken h is so small that AB is approximated as the curve. That means AB is a straight line. I will show it separately here. This is the curve and AB is a straight line. The gap between points is equal to h. H is very small. Tending towards 0 means this is very small. So AB can be approximately, we are moving a straight line AB, there is not much difference between the length of the curve and the length of the straight line. So with the help of this you can define what is the differential coefficient or the derivative of this. So suppose this point is M. So the derivative at any point is defined as, you know, the definition of derivative at x equal to a, f dash a, also known as dy by dx at x equal to a is f dash a. This is equal to the slope of this line which I had drawn, AB, and the value of y, that means bm divided by am. So f of a plus h minus f of a. Here the value is f of a plus h, this value is f of a, so this value minus this value divided by the base, that is equal to h, where h is very small, h is tending towards 0. This is how we define the differential, the derivative of a function y equal to fx at any particular point x equal to a, provided that the function is continuous. This I have assumed function is continuous at this point, so the derivative exists. Or we can also write that limit a, h is very small. What is meant by this? H is very small means the distance between a and b is very, very small. So I can also write that limit a tending to b, you can see that a tending to b, and this is equal to bm divided by am, perpendicular upon base. So it means that when h is very small, the 2 points a and b will be close enough, they are approaching towards each other. What does this mean? That when a and b approach each other, then we can draw a tangent here at this point, I can draw a tangent at this point, and this tangent is making an angle this is the tangent when a approaches b. In that case a and b become almost same point, and so we can draw a tangent here at this point. So this tangent is making an angle, say phi or theta, with the positive direction of x-axis. So this expression can be written as equal to tan of phi. So I can write that f dash a is equal to tan phi, which is the slope of the tangent drawn at this point where we have to find the derivative. So this is the physical meaning of the derivative. Now we can find some derivatives by using this principle. So this is known as the first principle. We have to find the derivatives with respect to this, and when you solve the questions for from the chapter of derivative, first of all you should find whether it exists or it does not exist by calculating the right hand and left hand side of derivative. That will be discussing separately. So we will be using this formula for the purpose of making the calculations for finding the derivatives. This is known as the first principle or the basic principle. Now there are different types of functions. A question arises that for a function y is equal to c, c here is a constant. What is the value of derivative? You all know that dy by dx is equal to 0 for y is a constant function. So why does the derivative for a constant function becomes equal to 0? The answer is if you plot a constant function y equal to c, it is making an angle of 0 degree with the positive direction of x-axis. It is parallel to the x-axis. So tan phi is 0. That means dy by dx is 0. That means the slope of this function is 0 with positive x-axis. Similarly, if you have a function like this that is making an angle of 90 degree with the positive direction of x-axis, it can be written as x equal to a. So in that case, phi is 90 degree. So I can write tan phi is tan 90, which is tending towards infinity. So in that case, dy by dx is tending towards infinity, means dx by dy is tending towards 0. So this is how we write the derivative, and this is the meaning of the derivative. Now we can find the derivative of various functions. Suppose I write a function y equal to x. What does this mean? If I show this graphically, the function can be plotted as a line making an angle of 45 degree, which remains constant with the positive direction of x-axis, means in this direction. So here phi is 45 degree. For any point, if you take any point on this graph, this angle remains same. So dy by dx is equal to tan 45 degree. This is equal to 1. So this is how you can find the derivatives. Now let us use the basic function, the definition of derivative, which I had just written, or that is also known as the first principle, to find the derivative of a function. F dash x is equal to f of x plus h minus f of x divided by h tending towards 0. This is a derivative, how it is defined. Suppose I have a function fx equal to x raised to the power n, and I have to find the derivative. So f dash x, or d by dx of x raised to the power n, this is equal to x plus h to the power n minus fn xn. Here fx is x to the power n, fx plus h is x plus h raised to the power n divided by h. H is very small. We can solve this, and here you can use the concept of binomial theorem, taking x common from this, x to the power n, 1 plus h by x to the power n minus xn divided by h, limit h tending towards 0. xn common, divided by h. Now you know that from binomial theorem, if you expand a plus x raised to the power n, then this is equal to a, or in place of a I will write 1, because here we have 1. So this is 1 plus nx plus n minus 1 x square by 2 and other higher terms. So here, if I leave the higher terms, if the value of n is small, then leaving these higher terms, we will be getting these two terms. So xn, 1 plus nh by x minus 1 divided by h. 1 cancels out. So this is h tending to 0, n x to the power n minus 1 into h by h. H cancels out. So n x to the power n minus 1, this is the value of the derivative. So this is how you can find the derivative of a function. So this is n x to the power n minus 1. Suppose if we have fx equal to x to the power 5. This n can be an integer or can be a fraction also, n can be positive or n can be negative also except 0. So f dash x is d by dx of x raised to the power 5, which is equal to 5x to the power 5 minus 1 or 5x to the power 4. This is the basic formula of differentiation that is known as the first principle. So you can find any derivative by using this. Let me solve one more problem by using this formula. Fx, let us take, equal to 1 by x. So I can write f dash x is h tending towards 0, 1 over x plus h. Here in place of fx plus h, write x plus h in the function. So 1 divided by x is 1 by x plus h minus the original function divided by h. So this is equal to h tending towards 0, x minus h divided by hx into x plus h. X square plus xh. H will be cancelled out. By putting the limit, this is equal to minus 1 by x square. On the other hand, it can also be written as fx is x to the power minus 1. So dy by dx is f dash x, n here is minus 1. So minus 1 x to the power n minus 1, which is minus 1 by x square. This is how you can solve these algebraic functions. We can solve another type of function. Any other type of function can be solved by using this, be it a trigonometric function or any other type of function. Let us take the example of a trigonometric function. And let me remind you that these functions, be it a polynomial function or the trigonometric function or the logarithmic function exponential, they are always continuous. So fx equal to sin x. We have to find the differential of this function or derivative of this function. So f dash x is h tending towards 0, sine of x plus h minus sine of x divided by h. And we have to solve this by using the formula of sine of a minus sine b, that is 2 cos a plus b by 2 cos sine a minus b by 2. 2 cos x plus h, so 2x plus h divided by 2 sine a minus b, x plus h minus x divided by 2 divided by h. 2 cos x plus h by 2 sine of h by 2 divided by h. So we can write this as, if you write 2 here, cos x plus h by 2 sine of h by 2 divided by h by 2. H is tending towards 0. Now if you put h0 here, this is cos x into h tending to 0 sine of h by 2 divided by h by 2, and this as per identity is equal to 1. So this is equal to cos x. So derivative of sin x becomes equal to cos x. This is how you can find the derivative. Now we have other type of functions which are a combination of different types of functions. Before doing this, let us find the derivative of log x to the base e. So dy by dx is, by using the definition of the function, and dy by dx we will get as equal to 1 by x. For log x, this is equal to 1 by x. So log of x plus h minus log x divided by h is tending towards 0. So I can write this as log of, if you take x outside this, 1 plus h by x minus log x divided by h is tending towards 0, and log of a into b is log a plus log b. So log x plus log now we will expand the log 1 plus h by x by using the formula of expansion. And you know that log 1 plus y is equal to y minus y square by 2 plus y cube by 3 minus y4 by 4 plus and so on up to infinity. So here this is y is h by x minus h square by 2x square plus and so on divided by h. If you take h common from this, 1 by x minus h into 1 by 2x square and other higher terms divided by h. H cancels out. When you put the limit of h, the answer is 1 by x. So this is how you get the derivative of log x. Now there are certain properties as far as this derivative is concerned. If you have a function ax, f of ax, where a is a constant, x is a variable, y is equal to this, then dy by dx is equal to d by dx of f of ax. The constant is taken outside, a f dash of ax, or you can write this as f dash of x. Now for example, function is y is equal to 4 e to the power x. So this gives dy by dx is d by dx of 4 e to the power x. 4 is a constant, so 4 d by dx of e to the power x. This is equal to 4 e to the power x. This is how you get. Now we have used the function exponential x. Let us find the derivative of this using the first principle. So y is equal to exponential x. So this gives dy by dx is h tending to 0 e to the power x plus h minus e to the power x divided by h. E to the power a plus b is e to the power a into e to the power b. This gives h tending to 0, e to the power x can be taken as common, e to the power h minus 1 by h. We have to evaluate this limit, and e to the power y is 1 plus y square by 2 factorial and other higher terms up to infinity. So this is h tending towards 0, e to the power x 1 plus h square by 2 factorial, and other higher terms minus 1. 1 cancels out. If you take h common, then this h will be divided, so we get 1 plus h by 2 plus other higher terms. On putting the limit, the answer is e to the power x. So differential of e to the power x is equal to exponential x, or it remains same. So this is how a function when multiplied by constant, derivative of constant will be 0. So constant is taken out and we have to differentiate only this function. If we have two functions, u is also a function of x, v is also a function of x, and there is a function u plus minus v. Suppose z is equal to this function, or w is equal to this function. So we have to differentiate this with respect to x. This is du by dx, or du plus minus v. So du by dx plus minus dv divided by dx. So in this way you can write the differential of this function. Suppose I have fx, which is y or w, whatever you write, x square plus 2x plus 3. So there are three terms: variable multiplied by a constant, and this is constant. So I have to find dy by dx. So dy by dx of x square plus 2x plus 3. So dy by dx of first function x square plus second function multiplied by a constant. So I will write the constant separately, plus d by dx of a constant function 3. Now differentiate this. D by dx, x raised to the power n here is equal to 2. So nx to the power n minus 1. So 2x to the power 1 plus 2 dx by dx, derivative of x as using this formula is 1, plus derivative of 3 is 0. This is a constant function. So the answer is 2x plus 2. This is how you can find the derivative of the function which is expressed as a sum or difference of two functions. Now we can find the derivative of a function which is expressed as the product of two functions with same variable. U and v are two functions of x, and we have y is a function of u and v. U and v are functions of x. So y is also a function of x. We have to find dy by dx. So this is given by d by dx of u into v, u dv by dx plus v du by dx. So this is how you can find the derivative. Suppose y is equal to x square sin x. So this is u, this is v. So I can write dy by dx is d by dx of u into v. So this is u into d by dx of v plus v into d by dx of u. So this gives us derivative of sin x is cos x, we have just solved, plus sin x into derivative of x square is 2x. This is how you can find the derivative of a product of two functions of same variable. Similarly, you can find the derivative of a function which is expressed as the ratio of two functions, or simply saying u by v. U and v are functions of x, y is u by v. So I can write v into du by dx minus u into dv by dx divided by v square. Du by dx first derivative can also be written as u dash, dv by dx is v dash. So v u dash minus u v dash divided by v square. The dash represents the number of the derivative, first derivative. So dy by dx is f dash x, first derivative. Second derivative d2y by dx square is d by dx of dy by dx f double dash x, and so on you can write. The nth derivative is written as f of n dash x. So now we can find the derivative of a function. For example, you have y is equal to cosec x, which is 1 by sin x. I have to find dy by dx. There are several methods of solving any problem, and we are discussing here some of them. As the discussion progresses, you will find that the other methods can also be used to solve these problems. So here u is 1 and v is sin x. Here I have written that u and v are a function of x. So here I have taken u is equal to 1. So this is not a function of x. I can write u equal to 1, which is x raised to the power 0, becomes a function of x. I can write it this way or this way also. This is sin x into d by dx of the constant function 1 minus 1 into d by dx of sin x divided by v square sin square x. Derivative of 1 is 0. So 0 minus derivative of sin is cos x by sin square x. So this is minus cosec x cot x. This is how you can find the derivative of a function which is expressed as the ratio of two functions. Now apart from these, we have composite functions. Suppose the function is y equal to tan of ax plus b whole square, where a and b are constants. You have to find the derivative of this. So first of all, you should know how to find the derivative of tan x or tan ax plus b. This for this purpose you can use the basic principle or the first principle I have just mentioned. So y is equal to tan x. I am just writing tan x derivative. Can be written as sin x by cos x u by v. dy by dx is v into derivative of sin x minus sin x into derivative of cos x divided by cos square x. So cos x into cos x minus sin x into derivative of cos x is minus sin x. So cos square x plus sin square x upon cos square x, 1 upon cos square x, because this term is equal to 1, cos square x plus sin square x. So this is sec square x. Now in this type of problems, first of all you have to assume that this is a single variable. Ax plus b can be expressed as a single variable. And now we have to differentiate this function with respect to that single variable. Suppose ax plus b is kept as capital X. Now we have to differentiate this. The function is tan of this. So y is tan of x square. What we can do here is we have to find dy by dx. See the change. Here this is small x, so dy divided by dx. Here we have capital X, this is dy divided by dx. One thing you should note that tan of x square is not equal to tan of x whole square, because this is tan square x. So this is just the square of x, so it should be included in the brackets. The students generally make this mistake. They understand that tan of x square is equal to tan x whole square, which is equal to tan square x. So now I have to differentiate this. So what is the differential of this with respect to tan? First differentiate for this tan of x square. That means you have to concentrate only on this tan function. And differential for tan is sec square of the function. So sec square x square. This will remain same. Multiplied by, now we have to find dy by d of small x. And this is how we have found with respect to this capital X. So for this purpose, we have to use a rule that is called the chain rule. The chain rule is defined as dy by dx is equal to dy by d of x into dx by d of small x. So dy by d of this you have found. Now what we have to do is we have to find derivative of this function with respect to small x and multiply them. So this is, first put the value here, sec square, putting the value of x square, ax plus b whole square, multiplied by d by dx of x square. D by dx of ax plus b, or you can simply write derivative of this by using the same formula, nx n minus 1, 2x raised to the power 2 minus 1. Now d by dx of x with respect to small x. Now putting the value of x here, this is not the sign of multiplication, this is capital X. So 2 into ax plus b, putting this the value of x here, sec square ax plus b whole square, multiplied by d by dx of ax plus b. D by dx a here is a constant, a into d by dx of x plus d by dx of b. B here is constant, so derivative of this is 0 and derivative of x is 1. and you can write a here. So 2a ax plus b sec square of ax plus b whole square. This is the answer to this question, and this is how you can rule. You can use the chain rule. In case we have more than one variables involved, the chain rule has to be used. So in our discussion today, we have discussed how to find the derivative, what is meant by the derivative, and how we can find by using the first principle of the derivative of various functions, and also to find the derivative of composite functions and how to use the chain rule. So this is all for today. Thank you very much.